This is the Focus Applied Technology Hypermileage chassis dynamometer. It's designed especially for university competitions like the Shell Eco Marathon, electric motorcycles and bicycles, as well as conventional motorcycles. It weighs about 18 kilos and can absorb up to about 6 kilowatts of power. The driven wheel sits between two rollers, the rear driving an internal eddy current dynamometer. The front one is an idler roller, preventing the vehicle from rolling away. On the inside, you can see our own eddy current dynamometer is coupled to the driven roller via a 2-to-1 belt ratio. Speed and torque are both measured at the dynamometer, and the current going into the dynamometer controls directly the load on the rear wheel of the vehicle. The dynamometer controller provided with this dynamometer is very advanced. It allows direct control over the load, as well as a speed control mode, a torque control mode, and a road load mode. In the road load mode, the load the vehicle sees is going to be very similar as to what it would experience on the road. A final control mode is the computer control mode. In computer control mode, the computer determines what mode and what set point will be. It can also command the position of the throttle. This allows closed-loop drive cycle testing automated. On the back of the controller, you can see another nice feature. We have several spare analog input channels. With this, we can read things such as the battery voltage and current, or perhaps the air-fuel ratio. It's extremely handy when tuning a vehicle. Of course, we also provide software for graphically viewing the data during testing and for data logging. When we log the data, it can be saved in a file so that you can analyze it later with some other software. This shows the appropriate mounting of a conventional 100cc 4-stroke motorcycle. The dynamometer controller has been connected to the dynamometer, and we'll be looking at the dynamometer screen for analyzing data. I'm going to open the throttle, increasing the speed. I'll then increase the load, slow it down. Thus we can trace out the engine's torque curve. Data from the dyno controller is stored as a comma-separated variable file for easy importation into Excel or other programs for further analysis. Here we're looking at a time series of some data taken from an electric motorcycle. In the upper graph you can see the speed of the vehicle as well as the current and torque of the motor. You can notice clearly that the motor torque is directly proportional to the current. In the lower graph, you can see the electrical and mechanical power consumption of the motor, noticing that the efficiency is highest right about the highest power consumption point. More complex analysis are also possible using this simple software like Excel. Here's the wide open throttle torque curve of the motorcycle as well as a road load curve. This indicates where the two lines connect the top speed of the vehicle on the road. On the right, we see a snippet of the screenshot taken from the dyno logging program during testing. Finally, in the graph on the bottom, we can see a theoretical torque and power curve from an electric motorcycle. You'll notice that the torque, the actual data, follows very closely the trend of the theoretical torque, as does the power. That's as it should be. Complex analysis like this are actually fairly simple with this Hypermileage dynamometer program. For more information, a manual, product information, or a quote, please visit our website.